Hello. In this video, we will look at a problem with similar triangles. Similar triangles are those where the angles of two triangles are equal and the ratio of the corresponding sides of the two triangles are equal. And we will look at one problem on Pythagoras' theorem. So let's get started. The question is, refer to this figure below and we are supposed to find the perimeter of the triangle A, B, and C, and the area of the same triangle. So it looks like we need to figure out the length of BC and the length of AC. Let's go ahead and determine if this triangle is indeed similar. Well, we know that this angle and this angle would be congruent because they're vertical angles, and vertical angles are congruent, and they both have 90 degrees. So by angle-angle theorem, triangle ABC is similar to triangle DEC. So if we can assign side BC as x, we can set up a ratio of corresponding sides as being equal. So we can say that x of one triangle divided by the corresponding side is equal to 20 divided by 8. And we can calculate x using our calculator. 20 divided by 8 times 15 is 37.5. You can choose to do the ratios of the corresponding sides again, or you can choose to use Pythagoras' theorem to find the length of the side AC. I will use Pythagoras' theorem. So AC squared is equal to 20 squared plus 37.5 squared. And again, using my calculator, I conclude that the length AC is 42.5. So this side is 42.5 and this side is 37.5. We are asked to find the perimeter, which means we have to add 20 plus 37.5 plus 42.5. And the final answer is 100. So we put 100 here. And then we bubble 1, 0, 0. The next one is the area of the triangle. We know that the formula for the area is half base times height, half base length times height. Base length is 37.5 and the height is 20. You can reduce 2 and 20. It's easy to multiply 37.5 by 10 without the calculator. The final answer is 375. So it would be 375. This is 3, 7, and 5. 375. Very good. The next problem is on Pythagoras' theorem. The question is, what is the value of PS in the triangle here? So if you can look at the two triangles separately, let's see if we can pull this out. And the PQ, this is side PQ. This is side PQ, and this is also PQ. This is 90 degrees. Call this one R and this one S. If we want to figure out the length of PS, we know that this side is 5 and this is 20. And if this piece is 11, then QR would be 11 plus 5, which is 16. So by Pythagoras, we can figure out PQ. So 20 squared minus 16 squared will give you PQ squared. Using our calculator, we conclude that PQ, the length of PQ, is 12. So this is 12 right here. This is 12. And we know the length of QS, and we can use Pythagoras again and figure out the length of PS. So this time it'll be 12 squared plus 5 squared is PS squared. So use your calculator to determine the length of PS, and it is 13. The length of PS is 13. It is also possible not to use the Pythagoras theorem because it's a 5, 12, 13 triangle, which I have not covered in this video. I find that the less you need to memorize, the better it is. So you can always use Pythagoras theorem. So you don't really need to remember too many things. That's it for this video. Thank you very much for listening. Goodbye.